So, I'm going to talk about OpenStack and openSUSE. It's mostly actually I talk about OpenStack because I think a lot of people heard about OpenStack but don't really know what this is. And at the end there will be some bits about OpenStack in openSUSE. And so in case you don't know me, I'm Vincent Untz. I'm actually working on the cloud product at SUSE. And so I'm trying to understand what OpenStack is also. So I'm like you. Okay, first, probably about the cloud in general. I think what's important is that everybody knows that cloud is really a nice word and it means a lot of things and so on. So I'll try to use some of these words. Innovative, leading, I can say that, groundbreaking, yeah. Takeaways, I will forget that one, but so try to see all the buzzwords in what I will say. So the definition of cloud is, it really depends on a lot of people, but there's one definition which is from the National Institute of Standards and Technology in the US, I guess. So I won't read it, but what's important is what is in bold in the text. So cloud computing, so it's on-demand, configurable computing resources, rapidly provisioned and released, minimal interaction, blah, blah, blah. So what matters for most people actually is really the on-demand. So you really need something, you ask for it, you get it, and you get it fast. You don't have to go through a long process where you interact with like a huge hierarchy and it takes weeks and weeks. And you can dispose of it when you're done. It's also very fast to get rid of that. And so that's cloud computing in general. But the thing is that when we talk about cloud, like a lot of things are cloud. So OpenStack is cloud, but like Google Plus is cloud. You have everything in Amazon Web Services, which is cloud. A lot of things, OpenShift from Red Hat and so on. And so you actually have different cloud models. So I think it's really important to understand the difference between the three of them. Actually, you have more of that, but that's really the three things that you always see, more or less. For a change, I'll start from the right. So software as a service, it's actually everything that you use online, more or less. It's like Google Plus, Hangout, whatever. It's all the software that you use either from your web browser or on your phone, which is interacting with something. So it's made for end users directly. That's it. Often below software as a service, you have something which is platform as a service. So not necessarily, but often they go together. And platform as a service is made for developers. So they have an application, so they write an application using some framework that can be based on Python, Ruby, whatever. And they want that to be scalable somehow, and so that they know that they will need at some point possibly more servers that will be deployed with that same stack and so on. And that's why we use platform as a service. So they have their application, they wrote their application, they push it there, and somehow it will scale magically. And then below that, you have infrastructure as a service. And this is really for people who take care of the whole infrastructure that will run a lot of things. So in general, this is really for people who want to say, I need some compute power, I need some specific network between different nodes, I need some disk space, and so on and so on. And so this is really low level compared to everything else, and this is really the part we're looking at with OpenStack right now. OpenStack is actually growing, and so it's moving in all directions, and so slowly also going towards platform as a service. But the core of OpenStack is infrastructure as a service.
So it's OpenShift?
OpenShift is platform as a service. And yeah, I mean, there are several alternatives to for platform as a service. OpenShift is one, and you have other ones. Yeah, so keep that in mind. I think actually if there's one thing to remember about cloud, it's probably that, because that makes it it makes it easier to understand when people talk about cloud that they actually don't talk about one thing, but about several things. One other thing which is important and which was made popular some time ago is the analogy of pets versus cattle. So the idea in cloud is that you actually don't care that much about what you get. It can be shut down, it can disappear, it can crash. What matters is that you will get some more anyway at some point. And it's really cattle. And compared to the old way of doing things where you have either a server or your small VM, and you take care of that, you make sure that it's well configured and you maintain that carefully, and you don't want it to crash. Maybe you had high availability, but it's still something that you want to keep. And this is something where you're very careful about it. It's a small bet, more or less. You make sure that it goes well and it's always healthy and so on. So that's really the difference between something which is in the cloud, where it's using resources that can disappear, and anyway the app will survive, and something which is not in the cloud, where you want to make sure that this survives. And a good example of that to illustrate that is actually what Netflix has been doing. So you might have heard of that. Netflix is, so you all know about Netflix, I guess, in general. So their app is actually deployed in the cloud, and what they did to make sure that it's really reliable and so on, that they developed something, a software, which actually kills from time to time some part of the nodes which make their application. And so the goal is that the application should survive that, because the application is built on top of cattle. And so it should be still able to run after that. And this really illustrates the fact that when you build something for the cloud, it's really totally different from when you build something which is for the traditional way. You really have to take into account into the design of the application that what you have below might disappear, and you have possibility to restart something at some point. So that's really the general bits about cloud. And let me talk a bit about OpenStack. So that's the nice logo. Beautiful. So OpenStack is a project which was actually started in 2010 when people from NASA and from Rackspace met and realized that some of the bits that they developed were actually, they had a similar architecture. They were not doing the same thing. So there was one bit which was really to start compute resources, so like virtual machines, instances. And there was one bit which was about object storage. So you upload something and you can download it again. But they realized that it was architecturally similar. So it was written in Python. They were using REST and so on. And so they thought about it. And at that point in time, the Amazon Web Services were starting to be really visible, and people knew about that. And so they realized that they could form a project together, and this project could be a free software alternative to the Amazon Web Services. So it's released under the Apache 2.0 license, free software. What's really interesting is that it's moving very, very fast. So it's only 4 years old, going to get it. And it started with 2 projects, and slowly, you will see that afterwards, it grew. It's bigger and bigger. And the fact that it's moving that fast is actually good in terms of what it covers, but it's also really bad because it's really hard to keep track of that. It's really hard to know what the goal of the project is, and it's hard to know when to say, no, this should not be part of OpenStack, or yes, it should be part of OpenStack. So there's a foundation to, they have a lot of money, and they deal with all the organization stuff like organizing the summit and legal issues and so on. OpenStack has a 6-month release schedule, so it's modeled after a lot of free software projects. Shameless plug, GNOME made that popular. And so iSouth got released, when are we? 2 weeks ago now, I think. So iSouth is the last release, and the next release is due in October. And what we have in OpenStack is also a 6-month summit every 6 months, so that we can start organizing and preparing for what we plan to do in the next release cycle. So in 2 weeks from now, people are going to gather in Atlanta for the next OpenStack Summit. It's actually very huge. It's like 4,000 people. It's really huge, terrible. What's interesting about OpenStack is that in only a couple of years, it managed to attract a lot of companies. And actually, if you look at this list, which is, so this picture is like, I've been starting to use it at least 1 year ago. So it's old, outdated, and so on. But if you look carefully at it, you will see probably all the big names in the industry, except Google and Apple. But everything else should be more or less in there. And so this is really crazy, actually, if you think about it. And that really means that all of the industry put its weight behind OpenStack. And that's really the project that is, if there's one that is going to succeed for the free software cloud, it's going to be that one. And so many people think about OpenStack as the Linux of the cloud in the end. The goal is really to reach the same success as Linux. Whenever you need to do something which is supposed to be about cloud, you would build that on top of OpenStack. So that's really the goal. We're not there yet, but when you see all the people using it and all the people talking about it, it can be there really fast. The other bit which is interesting about this comparison is that if you look at how Linux progressed over the years, it was quite a slow start in the end. It took like really 10 years to be ready for the enterprise. And for OpenStack, it's much faster. So now, it's going to be the interesting part, if I don't go backwards. I'm going to show you a bit about how OpenStack is architectured. So this picture is from OpenStack ASX, which is 2 years old, I think. You see there were 5 components. They were interacting together. Looks not that complex. I mean, you see the 5 components. Okay. The reality of this picture is actually more like that. So each of the components is actually made of several subcomponents, and they're all talking to each other in different ways, and it's starting to be a bit crazy. So you can start seeing the complexity of the project. But if you take a few releases after that, so that's probably Grizzly or Folsom, so 1 or 2 releases after ASX, you have more boxes, still a simplified version, but starting to be a bit messy. And then when you look at the details, it's starting to, well, it's not even readable actually. But you see all the boxes, sub-boxes, arrows in all ways and so on. It's a huge mess somehow. It all made sense. It all makes sense if you really look into the details and you try to understand, but it's very hard when you first approach it and you're like, okay, where should I start? You don't know. It's so huge. And so I told you this is from Grizzly, I think, but this is still growing. It's missing a lot of boxes. So like telemetry, ceilometer and heat, so which are for telemetry and orchestration, have been integrated a few releases ago. Trove got integrated in Icehouse. And then we have at least 3 incubated projects which are not officially OpenStack yet, but are going to be part of OpenStack at some point. So that's 6 more boxes, and there are more. I mean, always more. So if you look back at this diagram, it's just, I mean, you need the whole wall at the end to see something. And this gives you an idea about the main issue with OpenStack is how you deploy it. I mean, you have all these things, and actually, if you look at all the details, you need to manually configure all the components. So if you do that manually, it's like more than 1,000 options. What do you do with that? I mean, how do you configure that? Do you even know how many nodes you need to deploy all that? So it's just crazy. It's not something that well, some people do that manually, but let's say, yeah, they're crazy. So it's really currently a hot area of development. There are several approaches to solve this issue. So at SUSE, we have a product which is called SUSE Cloud that we use for that. It's based on a deployment framework which is called Crowbar. But it's pretty cool, actually. I mean, it makes most of the things automatic, and it's kind of magic. But there are several other alternatives, and this is really one of the biggest challenge of OpenStack right now. It's difficult. Andy, do you want the microphone?
So, if you've got like 1,000 options, etc., for configuration, would it help to get users that are going to be deploying this to use KDE first?
You don't want me to answer that. No, but more seriously, it's really different. The main difference is that, well, maybe it's not that different. I don't know the KDE community that well, but the way the OpenStack project is working is that by default, it's open to everything. So somebody wants something in, it gets in. As long as the code is solid, there are unit tests and so on, it can get in. That's really the thing. So that's why there are a lot of options. There are a lot of things which you can do one way or another, and yeah.
So how many alternatives to Crowbar are there?
Well, I don't know all of them, but so it depends at which level you look, because Crowbar is really a full solution where it's made, I would call that for end users, but you know, it's cloud operators. But you have solutions which are really just made of a thin layer above Chef or Puppet. You have alternatives which are more or less at the same level as Crowbar, like Fuel. You have an effort as part of OpenStack, which is called Tripolo, which is really promising, but right now it's made more for huge deployments like the HP public cloud, you know, like thousands of nodes. So it's not exactly the same use case, which leads to different issues somehow. But there are several, quite a lot actually.
Would it be possible to use, like on openSUSE, would it be possible to use, say, Juju?
Juju.
Because there are RPM
It's always
packages.
possible. You know, it's always possible, just a matter of doing it. I don't think it's a good idea, but I mean, I've never looked at the code of Juju, so it should be possible to port it, but I think it's a lot of effort, and it's actually, I have no idea. It's just unclear to me if the maintainers of Juju would be taking the time to review all the batches to port to another platform, because they're really Ubuntu-centric, being employed by Canonical. So, but that's possible. The issue with the Juju, I would say, is that it's very nice as a first interaction, but it's not that good. So I don't think it would be worth it, to be honest. Going on? Okay, going on. So I won't talk about how to deploy that. That would be a really totally different talk. And I would probably talk too much about the product I'm working on. So the typical deployment of an OpenStack cloud looks more or less like that. As you can see, this picture was made of, not really nice, but anyway. More or less, you have a user somewhere. You have one control node, which is running, I would say, all the intelligence of the cloud, so all the servers which are the API servers, the schedulers, and so on. And then you have compute nodes and storage nodes. This is actually a simplified view, because usually a cloud which is large with quite some nodes would have not just one control node, but would have the services spread across several control nodes. But you can do it that way. And so what's interesting is that you see all the compute nodes, that's really one of the resources. It's really the compute resources. That's what you have at a large scale. And you have also the storage nodes, which really is where you store all the data. So it also can be quite big. And so to simplify, you have on one side everything which is about how you do things, and on the other side everything which is really, I would say, the cattle. It's the same thing, more or less. As you can see on this slide, you can actually have several hypervisors on the compute nodes. I'll talk a bit more about that later on. So vCenter, Hyper-V, Xen, KVM. I'll try to go back on this one. I'll take your microphone again, actually, because I'll show things. Yeah, it's like. So, I'll have to jump. Let me show you a bit the different components we have in OpenStack. So if we start at the bottom, we have Keystone. So this is this bit. It's all about identity, authentication, registry of the services, and so on. So everything is talking to Keystone, to simplify. That's how we know about users, what they are allowed to do, and so on. Then we have, let's go there. This is Swift. So Swift is the object storage project in OpenStack. So that's where you put one blob, can be a file, can be anything. And so you put one blob in the object storage and you can get it back somehow. So it can be used for different things. For instance, you can actually, like, if you build a photo website, you can put all of the photos in Swift, and what you display, you actually display straight the photo from Swift. And the good thing about Swift is that it's really reliable. So everything is replicated. You can run it on really commodity hardware and so on. So it's quite nice, actually. There are alternatives to Swift, like Ceph, for instance, which is not part of OpenStack, but Ceph is also pretty nice, actually. Then you have Glance. So Glance is the part of OpenStack which contains all of the images that you will start as an instance. So that's like an ISO or a hard disk for your VM, to simplify. So that's why you put like your openSUSE image, Fedora image, Ubuntu image, and so on. It's one of the most simple parts of OpenStack, actually. So possibly one nice place to start if you want to contribute. Then you have Nova, the crazy bit. So Nova is actually, so that was one of the first projects of OpenStack, and we talk about it about the compute part of OpenStack. So that's where we say I need to start a VM, so I start it. It will find a node where to start it. It will start it. It will do all the different magic to make it work. And it's quite big, actually. And it was actually made of more sub-projects like Nova Network, Nova Volume, which were later split out of Nova because they're big by themselves. So Nova Volume was actually split in Cinder, and Cinder is the block storage part of OpenStack. So this is where you say, I need a hard disk for my virtual machine. And so it will create something, and you can plug that in your virtual machine. It's actually quite big because you need to be able to interact with all the different SANs around there, or with Ceph, with whatever other backend that you might want to use. So there was Nova Network there, but people decided that Nova Network was a bit old in design, and so they went to do something which is, so if you manage to read that, it's written Quantum, that's the old name, and it's called Neutron, and it's all about the networking of OpenStack. So if you want to say, I have my VMs, I need a network between the VMs, this network will work that way, that way, that way, and it will do all that. And it's a bit crazy, so it's a bit like you have inside Neutron, you have stuff like load balancer as a service, firewall as a service. So you can do crazy stuff automatically for your instances. And I wanted to mention something about Newsroom. I forgot. Whatever. You're raising your hand, Dykes? No? Okay. So that's really the basic parts that you need to run an OpenStack cloud. And well, actually, you don't need Swift if you don't want. Oh, I forgot. Up there, I cannot reach it. Horizon, the web dashboard, so end user interface. So yeah, that's the basic part that you need. And everything else I mentioned earlier, like heat, ceilometer, and so on, come on top of that and just come with additional features. Drop that one. Okay. So I won't talk in more details about each of the components because like I could talk about them for hours and hours. But what's interesting is the hypervisors. So I mentioned that earlier. So OpenStack is an open project. And as part of that, all of the people, as you've seen, I mean, the whole industry is behind OpenStack. And everybody who is using a specific hypervisor will want to have that as part of OpenStack. And so you see the list of a hypervisor that is supported. Everybody has been trying to push its own solution. And it's actually working quite well. So you have KVM, Xen, QEMU, LXC, UML. This is all based on libvirt, so quite convenient. And actually, KVM is the most used solution for nowadays. Most people just use KVM by default. It's working pretty well. But people might want to use Xen because they're more comfortable with it, for instance. Then you have Xen API, which is like the different version of Xen that is like made by Citrix and so on. You can have VMware, Hyper-V, Docker, PowerVM, bare metal, and so on. And what's crazy is that all of these hypervisors you can actually use together in the same cloud. So you can say, okay, I have one big cloud, and I want this instance to be running on KVM for one reason or another, and I want this one to be running on VMware or Hyper-V, and it all just works fine. So it's pretty nifty, and there are some good reasons to do that actually. So like VMware, a lot of people already have a VMware deployment. So you invested in that. Why would you want to buy a lot of new hardware and deploy a whole new thing if you can use directly that?
Can you migrate from one hypervisor to the other? So if you've got an instance running on KVM, can you migrate that to a Xen or Hyper-V powered instance? So
the short answer is more or less no. If you do migration, you actually need to have the same hypervisor below. What you can do is actually do some fake migration, where you take a snapshot or something like that of the sorry, of the system, and if it's compatible, you can start it again on some other hypervisor. So it really depends on the format that you use below that.
So could you use, say, KVM as the primary hypervisor or your primary cloud instance, and you've got a redundant instance running on Hyper-V. Could you fail over the workload, and then would that be a way of migration?
So say it again. You would it already be running on Hyper-V? Oh, that makes sense.
I would just say you write your application as cloud enabled, and then you can just switch the nodes over and it will just migrate. Stop thinking in the old way.
That's true. But what you can do is, so if you use an orchestration engine like Heat, what you can say is that if this instance is going down, then I do something, blah, blah, blah. And that could be what you mentioned. But what you need in that case is make sure that the image that you use as a basis for your instance can run on the different hypervisors. That's really the key in that case. What you can also do is prepare images for KVM and for Hyper-V, and then in the orchestration engine, we would just say, okay, if that happens, then I do something with this image there. But, I mean, that sounds a bit weird to me. I would just do live migration between two KVM nodes. In that specific use case, I mean, there are some good reasons to use Hyper-V and KVM in the same cloud, but your example doesn't seem that useful to me. One thing which is important to mention about hypervisors is that not all of the features are available on all hypervisors. First, because obviously they don't expose the same feature sets, but also because it depends on the community developing the backend for this hypervisor. And so it's something to really carefully consider when you deploy one hypervisor and you pick your preferred option. But in the end, I think this is quite nice to be able to say to people, okay, you might want to use all of your different backends with the same UI in the end. OpenStack is the common UI for all of these different things. It's quite nifty. So I could give more details about the technical bits of OpenStack, but I also wanted to talk about OpenStack and openSUSE. So I'll switch here, but if you have questions about OpenStack in general, we can go back to that. So OpenStack and openSUSE, there's been a small team working on that since 1 year and a half, 2 years. And in short, we ship OpenStack as part of openSUSE. We have in 13.1, they have a version of OpenStack. For the next version of openSUSE, we will have either iSauce, which went out 2 weeks ago, or Juno, the next version. We will discuss with like Kulo, because Juno is due in October, so for November it's a bit short. What's important is that we actually do not just package one version of OpenStack. What we do is we package all the versions of OpenStack that are still maintained. So OpenStack is maintaining the last 2 versions. So right now that would be Havana and iSauce. And we also package the master branch. And so we have projects in OBS like Cloud OpenStack, iSauce, where you can get a specific version of OpenStack. And what's really interesting is that we are lazy people, I mean, in the team working on OpenStack. And so we actually automated most of the packaging because, you know, it's easier to just do nothing and make the computer do all the work for you. So it's a bit small, but hopefully you will be able to see. You need to ignore one part, which is all of that. I didn't redo the schema, the diagram, but you get the idea, I guess. So what's happening, so if you look on the top left, what is in fuchsia, pink? Andrew, what color is this? So this is upstream, more or less. So people are just pushing stuff to the Git of OpenStack. And what we do is that we use one nice feature of OBS, which is called the OBS services. So if you went to my talk yesterday about nice things about magic tools for packaging, I mentioned that. I will mention that again, I guess. So we use this to actually fetch directly the code from Git, update the package, update the changelog and so on, build the package to make sure that it still builds and commits, and all that automatically without any interaction from ourselves. So that's really the part where we're being lazy. And so this is being done in a staging project. So for instance, Cloud OpenStack iSauce staging. And then on top of that, we run quite some tests. So there's more or less a gate where we run the same test as upstream to make sure that it's still working. So we run the test based on the packages. And if we see that the test pass, we copy the package from staging to non-staging automatically. And that makes it possible to actually have working package without anything to do on our side. So that's how all of the cloud OpenStack, iSauce, Havana, and so on are populated. The part where I'm a bit lying is that from time to time we actually look at the packages because the dependency might change, and so we need to update that to reflect what is done upstream. And we might need from time to time to also, package the dependencies. So so that's the first part about how we do that in OBS. But then we want to push that in openSUSE because openSUSE is not made just of some random OBS project. So we have a project which is called, so this one, I'll not jump, but you get the idea. The white one, which is called Cloud OpenStack Factory. And so what we do is that we say, okay, we're going to ship the iSauce version of OpenStack in the next version of openSUSE. So we take all the package from Cloud OpenStack iSauce and we put them in Cloud OpenStack Factory. And this project is a develop project for openSUSE Factory, and with some, again, magic tool that was developed for openSUSE, which is called OBS Auto Submit. The package gets automatically submitted to Factory and it enters openSUSE. So what's really nice is that most of that is automatic. We don't have to care that much about it. And well, it just works fine most of the time. Sometimes, it breaks, but we can fix that. So just to show you how we do that concretely, that's what an example of an OBS service. So we define it that way. Can I actually? No, you don't see my mouse. So this is a simple file that you put along the other files in a package, and this tells the services what to do. It could be run automatically by OBS every time you commit or on a periodic basis. What we do is actually that we mark all the services as disabled because we want to control when we run them, and we do that with Jenkins. We have a periodic job in Jenkins that will run all that. So the first service is called download files, and it has a parameter which is change generate. And what it does is simply downloads a table from a website. It turns out that OpenStack is pretty cool. It's providing a table for each branch that is updated every night. So we use that as basis. We download that. It's actually not version, so the name is something like Nova-Havana. So we download that, and with the change generate option, we're actually able to pass the change log inside the table and to generate the change entry for the package. Then we have the set version service, so the second one. This one, well, it simply set the version in the spec file of the package, because when you download a new version, you need to update the spec file. So what it does, I just mentioned that the names of the package were something like Nova-Havana. So you don't have the version in the table name, but inside the table, the directory is actually named Nova-2013.2. blah blah blah. So there's the version inside the table. So it goes fetch that there. There's a third service, refresh patches. I won't talk about it here. Go watch the video from yesterday. That's probably easier. So we have all that, and then we have a Jenkins job. So this is on ci.opensuse.org, so you can see that. It's all, it's all visible, all public. And you can see there all of the jobs that update the packages for all of the OpenStack packages. So we have Havana, iSauce, and master. And more or less what it does is it runs the services that I just showed. So it updates the package that way, it builds the package, and if the build is successful, it commits. And as you can see, there are some red bubbles, and that's the part where we actually look at things, because red means it didn't work. So we didn't commit. Usually a red bubble means that there was one patch, and the patch really needs to be refreshed or dropped or so on. But that could be something else. So what we actually do is we actively monitor that page or the mails that are being sent by Jenkins. Depends on the way we prefer, and we fix that. So it's pretty nice. I didn't take a picture, but there's also a Jenkins job to do the gating, as I mentioned, from staging to non-staging, and that will just take the packages, run the test, and if it succeeds, copy the packages. So pretty nice. So that's what we do to integrate OpenStack in openSUSE. But what we've been also doing is integrate openSUSE in OpenStack. Because that's important. We want the project to be visible to OpenStack developers. And so, for instance, Andreas Jäger worked on the documentation, and he did a huge amount of work to make sure that the documentation also reflects how to deploy OpenStack on openSUSE and SLES also. And so, if you go on the doc web page for OpenStack, you can see that we have a mention for openSUSE, which is pretty cool. The other thing that we did for that is Defstack. So Defstack is the small tool that people use, upstream developers of OpenStack, to deploy quickly a small OpenStack and test their changes and their patches. So it's really a core part of the development framework for OpenStack, and we made sure that it works fine on openSUSE. So there's a wiki page to explain that, but in short, that's an example of how you do it. You just clone from Git, you create a configuration file, you run a script, and at the end of the script, you have a deployment. It's pretty nice, and so in this example, it took like 6 minutes. It's really fast, actually. So that's one of the other deployment framework for OpenStack, except that it's really made for developers. But yeah, if you want to play with OpenStack without manually configuring it and with the possibility of quickly patching it, that's really the way to go. It's pretty nice. So there are a few other things that we'd like to do. For instance, upstream, all of the patches are being reviewed in Gerrit, and there are some bots which are actually commenting if the patch is passing all the tests in on a specific platform. So right now, this is mostly based on Ubuntu. There are also some tests for Fedora, I think. But we'd like to integrate with that, so every time somebody submit a patch for OpenStack, all the tests are being run on openSUSE to check that it's also working on openSUSE. So we'd like to do that. It's not that difficult. It just requires some time. So we need to find time for that. So I mentioned that we have a team for that. So we have a mailing list. We have an IRC channel. Everything is documented on the wiki page. Come join us. We're lazy, but we're not scary. So hopefully, you can work with us. And if you also want just to play with OpenStack on openSUSE, that's the place where you can get help for that, really. So that's it. Do you have any questions? Yeah, let's start with the non-ND guy.
Hi. For last year, we are testing in our company OpenStack, and for last 6 months, we are testing CloudStack. What do you think about this war between these two stacks products? It's very similar, but very different.
Yeah, it's similar and different at the same time. So I think CloudStack for a long time was really better than OpenStack. I don't think it's true anymore, and more importantly, the main difference I see that, as I said, everybody in the industry is supporting OpenStack. So that could be if you need hardware that is really supported or certified for OpenStack, that could be for storage, network, or just the compute nodes. this is easy for OpenStack. For CloudStack, I don't think that's as easy. But on the other hand, as far as I know, so I've never really played with CloudStack, but CloudStack I think is a bit easier to deploy and it's more user-friendly, at the beginning at least, but yeah. But really, I mean, for me the big difference is really that OpenStack is moving that fast. It's just crazy. I mean, there's no way that CloudStack can catch up with that. There's just no way. It's not possible. Anybody else than Andy?
You said everybody industry besides Apple and what was the other one?
Google.
Google, Apple and Google. What about Amazon?
Oh yeah, I forgot Amazon. Sorry.
So they
No, they obviously they. I mean, OpenStack. So Amazon Web Services is really for the public cloud. They don't have a private cloud solution, except that I think they did it for the NSA or CIA. I forgot, but they don't have a private cloud offering, but it's still competing with their business, so they don't support that.
Thanks.
So 3 groups, I forgot.
How long until SUSE Cloud installs as quickly as Defstack?
So 6 minutes, yeah, it's a bit difficult, 6 minutes. It can be very fast actually. I mean, I have some script to deploy SUSE Cloud from scratch and it takes 30 minutes.
That's good enough.
That's pretty good actually. I mean, but you know, it's made for me. But yeah, I mean, so yeah, I'll talk a bit about SUSE Cloud, but the deployment framework Crowbar is actually provides an API that you can interact with. So you don't have to do all things manually. You can just, you know, script all that. And what's taking time is actually taking a node from bare metal, which is not, that means no OS, nothing, and booting it and installing an OS on top of that. So that's the slow part, to be honest. So. The purple guy.
When's Crowbar going to be in openSUSE?
Why are you asking me a question you asked me yesterday?
So everyone else can hear.
Ah, I see.
And it's on record.
The issue is that right now Crowbar is working on SLES, Ubuntu, and to some extent CentOS, but it's not working well on CentOS right now. And so the people working on SUSE Cloud, so the team I'm part of, are actually interested in making it available on openSUSE, just taking time. And the reason for that is that so Crowbar is built on top of Chef. So if you don't know Chef, it's a tool that can be used to configure things. And the Chef recipes, so the scripts for Chef, are really, there are some bits which are specific to each distribution, and SLES 11 and openSUSE 31 or Factory are quite different nowadays, if only because of systemd, for instance. So it would require some work. It's not, to be honest, I don't think it's impossible. It's really just a matter of doing it. But we've been too busy to do it ourselves so far.
Can we not reuse what Ubuntu's doing now that they're going systemd?
What are they doing? What do you mean?
Well, because at the minute they're using, I mean, if you're saying one of the biggest blockers is systemd.
So no, so the issue is not that, you know, it's not about init scripts versus systemd services. It's not about that. It's really that there are some things which are like, let me find an example. All of the way you specify like a sysctl setting, which will be different nowadays. with the systemd, also the names of the services might be different. It's tiny. I mean, if you look at the high-level overview, it's definitely, we used to say, fairly doable, you know. But it's really the small details which are difficult, because you will not see the bug immediately, and once you get the bug, you're like, where does it come from? It's so huge. I mean, the chef cookbooks that we have are pretty huge, and finding the small bit which is wrong is not that easy. But if for people who are motivated, I think it's doable in like less than 1 month.
So if somebody's stupid enough to want to try and mess around with OpenStack,
You mean you?
maybe.
Stupid enough.
You know me so well.
Oh yeah.
Is there a quick and easy guide available somewhere, whether it be in the OpenStack docs or be on the wiki, etc., to get up and running? What the bare minimum needed is to get up? But you're saying that's OpenSUSE is not supported yet for Defstack.
No, for Defstack it's supported.
All right.
What is not supported is the patch review, more or less.
Right. Okay. And can that be deployed on a single
Yep.
piece of hardware
Yep.
without any
Yep.
issues?
It can, definitely. So what you will be doing in that case is that you will likely, it's using, it's the part which is ugly about Defstack is that to be able to configure OpenStack properly, it needs to change quite some system-wide settings. So you might not want to do that on your laptop directly, or you might want to do that on a laptop you don't care about. And after that, it's all fine. So you can run that in a VM if you want, otherwise.
Okay. Thanks.
It's pretty simple. There's actually another tool I didn't mention there.
I want to say to the Defstack paper, you aren't allowed to use passwords in the shell. You have to delete that after that.
With Defstack,
Yes, the Defstack paper. If you would use passwords in a shell, all other people can see that if you would do that as root or anything else, and you should delete that after that, or you can do that with the editor.
so obviously, I mean, the password that you see there are, it's to be used on a developer machine. It's not supposed to be a multi-user machine, to be honest. So I don't think it's a big worry. And the password that you see there are really for services that are needed for OpenStack, not for services that will be used to access your machine. So it's not really critical. What's a bit more annoying is that you more or less, Defstack needs to have root access. And so you need to use sudo for that. And so you more or less give root access to a script. That's what I would be more uncomfortable with. Hi, Michel. Hi. Is it time? We still have 9 seconds. Any last question? Yes.
Thanks. Andrew asked, what about OpenStack implementation for development or testing purposes? Rackspace have one shell script and a very good quick tutorial guide how to install a Rackspace implementation on one computing and storage node, and it's really good.
There's also something I completely forgot to include. I thought I did it, but I forgot. Well, let me show you. So for openSUSE, we developed something which is called OpenStack Quick Start. Blah, blah, blah. As you see, we don't have a lot of Google juice. This is not that one, actually. It is? Because, well, let's see. I'm not sure it's the right one.
I edited it the other day.
Well, do you want to talk about it? Because now you know this wiki page better than I do. Oh yes, it's mentioned. So actually you have a script that will just download the packages, install them, configure things, and boom, you're done. And you can run that also on some other nodes so that you have a multi-node setup. But it's a quick and ugly script. It's not like a real solution. It's used.
It's tested.
It's used for our gating. So it's tested.
Okay. Thank you.
Thank you, Michel.
And now time for the group photo. So
Group
everybody
photo.
outside.